This video is about solving systems of linear equations into variables by graphing, substitution, and elimination for 8th graders. 8th graders, welcome to your virtual classroom. Just a few reminders for your convenience. Get a sheet of paper and a pen to answer the exercises. To make sure you comprehend and follow through the concepts in the video, pause and replay the video at any time in any point. Now, you are ready. At the end of this video, you are expected to recall the systems of linear equations into variables and determine the solution of the given systems of linear equations using any of the three methods: graphing, substitution, and elimination. Now that we already know the objectives of this video, let's begin. Let's start this lesson by recalling your knowledge on linear equations into variables. Let us answer activity 1. Describe me. Draw the graph of each of the following linear equations in a Cartesian coordinate plane. We have 4 equations to work on. Number 1, y is equal to 2x plus 3. Number 2, 3x minus y is equal to 2. Number 3, y is equal to 5x minus 1. And number 4, 2x minus 3y is equal to 6. You can pause this video to solve for your activity. And don't forget, write your answers on a separate sheet of paper, labeled with your name, grade and section, quarter number, module number, and activity number. Were you able to draw and describe the graphs of linear equations into variables? Suppose you draw the graphs of 2 linear equations in the same coordinate plane. How would the graphs of these equations look like? You'll find out more when you do the activities in this module. Good luck and God bless. In the previous modules, we dealt with lines and linear equations one at a time. However, many situations in real life involve more than one linear equation and more than one variable. This requires that we solve a system of linear equations through graph and algebra. Here are the steps in solving linear equations by graphing. Number 1, prepare a table of values of each equation. Number 2, plot the points on the rectangular coordinate system and determine the solution of the system by finding the points of intersection of the 2 lines. Solving a system of linear equations through algebra has 2 ways: substitution and elimination. A system is a set of conditions joined by the word and denoted by a brace. For example, y is equal to 7x minus 3 and y is equal to 6x plus 2 can be written as y is equal to 7x minus 3 and y is equal to 6x plus 2 with the brace. Systems of linear equation means it consists of more than one equation and variable. To solve the system of equations in x and y means to find the ordered pairs that both satisfy the equations of the systems. Let us solve the following by graphing. Here are some examples for our comprehension. Example number 1, x plus y is equal to 10 and 2x minus y is equal to 2. Prepare a table of values of each equation. Assign a value either in x or y and solve for the value of the other variable. Here we have our table of values. We assign the x value with 0, 1, and 2. When x is 0, your y is 10. When x is 1, your y is 9. And when your x is 2, your y is 8. For the equation, x plus y is equal to 10. Now let's go to 2x minus y is equal to 2. When x is 0, y is negative 2. When x is 1, y is 0. And when x is 2, y is 2. Now that we have the table of values, we are going to graph these two lines. The equation x plus y is equal to 10, which is this line, and the equation 2x minus y is equal to 2, which is this line, intersects in the graph, which means that their point of intersection is the solution of their system, which is 4, 6. For our second example, we have a system of two equations, x plus y is equal to 6 and 2x plus 2y is equal to 5. First, assign a value either in x or y and solve for the value of the other variable. If x is 0, y is 6. If x is 1, y is 5. If x is 2, y is 4. For the other equation, if x is 0, y is 2.5. For x is 1, y is equal to 1.5. And if x is 2, y is equal to 0.5. Plotting these lines, 0, 6, 1, 5, and 2, 4, for line x plus y is equal to 6, and 0, 2.5, 1, 1.5 to 0.5 for the line 2x plus 2y is equal to 5, we get a graph with parallel lines. The two lines are parallel to each other, and therefore, they don't have a solution. And for our last example, we let x is equal to 0, then y will be negative 2. If x is 1, y is negative 1. If x is 2, y is 0. For the other equation, if x is 0, y is negative 2. If x is 1, y is negative 1. And if x is 2, y is 0. Our ordered pairs are 0, negative 2, 1, negative 1, 2, 0. For the line x minus y is equal to 2. And then we have 0, negative 2, 1, negative 1, 2, 0. For the line 2x minus 4 is equal to 2y. Graphing them, we have these two equations is in the same line, or they are coinciding, which means that they have infinitely many solutions. All the points belonging to those lines are solutions to the system. Here is the graphical comparison of the systems of linear equations. Intersecting lines at one point has one solution. Parallel lines, which means they do not intersect, has no solution. And coinciding lines, which means that they are on the same line, they have infinitely many solutions. Aside from graphing, a system of linear equations in two variables may be solved algebraically in two ways. One way of solving algebraically is through substitution. Now here are the steps in solving systems of linear equations by substitution. Number 1, select a simple equation in the system, either equation 1 or equation 2, and solve for x in terms of y or vice versa to obtain an equivalent equation. You may write in the form of y is equal to mx plus b. Number 2, substitute the equivalent equations to the other equation, then simplify. Solve the values of the unknown variable. For example, you want to solve for x. And of course, for step 3, you are going to be solving for y by substituting the value of the unknown variable to any of the two equations to find the value of the others. Then, we have to identify the solution and check by substituting the values to the variables in both equations. We have our first example, which is x plus y is equal to 10 and 2x minus y is equal to 2. Step 1, select a simple equation in the system, either equation 1 or 2, and solve for x in terms of y or vice versa to obtain an equivalent equation. So in this process, we are going to choose x plus y is equal to 10 because it can be easily be expressed as y is equal to 10 minus x. We are solving it in terms of y. Step 2, we are going to substitute the value of y, which we already know is 10 minus x. Applying the distributive property of multiplication and combining like terms, we can solve for x, which is equal to 4. Then, we choose the original and simplest equation to be easy. In this case, we choose our x plus y is equal to 10, substituting the value of x, which is 4, and we have y is equal to 6. Now, we are going to identify the solution, which is 4, 6, and substituting these values into both equations to check if they are really the solution to the system. And that's right. When we substitute 4 and 6 to x and y, 10 is equal to 10. In the same manner to the second equation, 2 is equal to 2. The solution, or the value of x and y, satisfies both equations, so the answer is correct. Another example, both equations are in terms of y, so just choose the simplest equation in the system. In this case, we choose y is equal to x minus 3. And then, we substitute the value of y, which is x minus 3. Combining like terms, then simplifying, we get x is equal to 2 and then we choose the original and simplest equation to be easy. In this case, it's going to be y is equal to x minus 3. Substituting the value of x, which is 2, we get y is equal to negative 1. Then we identify the solution, which is 2, negative 1, substituting it to both of our equations, and we were able to identify that the solution of the values of x and y both satisfies the equations. So the answer is correct. Another way of solving a system of linear equations into variables algebraically is through elimination method. Now here are the steps in solving systems of linear equations by elimination. Number 1, arrange the equations in standard form. Ax plus by is equal to c. Number 2, eliminate one variable either by addition or subtraction. Number 3, solve for the remaining variable. Number 4, solve the other variable by substituting the results in step 3 to any of the original equations. Step 5, identify the solution. And number 6, check by substituting the values to the variables in both equations. Let's try that with our first example, which is 2x minus 3 is equal to negative 5y and negative 2y is equal to negative 3x plus 1. Step 1, arrange the equations in standard form. So we have 2x plus 5y is equal to 3 and 3x minus 2y is equal to 1. Next, we select a variable to eliminate, either x or y. In this example, we eliminate y. Since they do not have the same coefficients, multiply both equations by a number to have the same coefficient to eliminate y. So, we multiply 2 in the first equation and we multiply 5 to the second equation. How did we know that? Because we want to substitute the values of y. So here, since it's 2 here, we multiply it to the first one. Since it's 5 here, we multiply it to the second one. And we get new equations which are of the same values. 4x plus 10y is equal to 6 and 5x minus 10y is equal to 5. Now, we can eliminate them by adding them together. We eliminate our y. So what's left is 19x is equal to 11. This time we solve for x, which is 11 over 19. Then we are going to substitute for x and solve for y in any of the equations. This time we choose equation 1 and we get y is equal to 7 over 19. Therefore, our solution set is 11 over 19 and 7 over 19. Now we check if our solution is correct. By substituting both values of x and y, our x is 11 over 19 and our y is 7 over 19. We get negative 35 over 19 is equal to negative 35 over 19, which is correct. It is also the same in the second equation. We get negative 14 over 19 is equal to negative 14 over 19. The solution or the value of x and y satisfies both equations, so the answer is correct. Going to our second example, we arrange the equations in standard form. We have equation 1, x plus y is equal to 10, and 2x minus y is equal to 2. Next, we are going to eliminate our y. Since they have same coefficients, we don't need to multiply them with any number. And we get 3x is equal to 12, or x is equal to 4. Now we substitute the value of our x, which is 4, to get the value of our y, which is 6, and we know that the solution set is 4, 6. This time we are going to substitute the values 4 and 6 to the x and y in both of our equations. Equation 1, we have 10 is equal to 10, and equation 2, we have 2 is equal to 2, which means that the solution or the value of x and y satisfies both equations. So the answer is correct. What's more, determine whether the ordered pair is a solution of the given systems of linear equations. Write yes if it is a solution, and if no, find the solution using any of the three methods. Write your answer on a separate sheet of paper. We have 3 numbers to work on. The solution of the systems of linear equations can be solved by graphing and by substitution and elimination methods. Congratulations! We just finished Lesson 1 of Module 11. This has been your teacher, Miss Mary Kate. Get involved and keep on learning. If you like this video, hit the like button. If you are new to my channel, please hit the subscribe button and the notification bell. Write your comments and suggestions in the comment section below.